Hi, thanks for coming to the talk. So today I'd like to briefly kind of discuss about a problem with code duplicates in the area of big code or machine learning on code. And this is a problem that I want to bring to attention this community, especially now that more machine learning work happens on machine learning. And specifically, it has affected how we evaluate and how we deploy machine learning models of code. So I hope that there will be some extra time for questions and discussions towards the end, but feel free to interrupt me if something is absolutely not clear. So first of all, let's start with what we know or what we have known for some time. So there is this work, I think it was published in Uppsala a few years ago, and what it says is that if you go on GitHub, scrape everything you can find, what you end up doing is having lots and lots of duplicates. So things that people copy-paste, or maybe packages that you imported and you, by mistake, added them into your version control, and things like that. So this paper has been out for some time, but I think this community, which is trying to look at machine learning for code, hasn't really appreciated what this means for the things that this community creates. So this is what I set out to kind of show here, not necessarily in an absolutely rigorous way, but showing enough examples to persuade you that duplicates are hurting us, and it's a problem that we need to look for. So first of all, let me explain what I mean by a duplicate, because there are many different ways of thinking about this. On one hand, you can think of it as clones, but I'm not thinking about clones itself. I'm thinking about file-level duplication, which means that smaller chunks of code that are copy-pasted are fine with me, at least for this work. But I'm looking at files that are not exactly necessarily exactly similar, but also are highly similar. So they might have small changes. And again, I want to emphasize that not all clones are actually duplicates. Small clones that are traditionally viewed in the software engineering and PL literatures are not necessarily a problem here. I'm talking about file-level duplicates. So let me show you some of those. And first, let me just show you some files in a paper that has been published, I think, in PLDI, from a data set of a paper that has been published in PLDI or Uppsala. So first of all, I don't even need to show you the code for these files here. Just looking at the names of those files should be enough. There is code mirror, code mirror, code mirror, different versions of this. And if I tell you that code mirror is an editor within HTML, you see that editor is here or CS console is here. So all of these things are probably exactly the same project, maybe slightly different versions, maybe small adaptations, but in the end of the day, they are doing almost the same thing. Of course, this could be exact, some of them could be exact matches, but there are cases where we don't have exact matches. So this is two files that I'm considering duplicates. This is actually a semantically equivalent file. It has exactly the same tokens, apart from someone who went and documented the code. So if you want to do a file level, an exact match between two files, you wouldn't find these two things. But if you do something a little bit softer to define the similarity between those two files, you see that these two things are the same. Yes, there is an extra comment here. There is an extra spaces here that have been removed, and so on. So for me, these two files are duplicate, and this is just a portion. It's not necessarily the whole file. And the same thing for the next one. So here now things become slightly more interesting. This is, you see a file that has a few thousand lines of code. Maybe you don't see it that far back. But you can see here things like, okay, some white spaces, but now some condition was added. But more or less, these two files are doing the exact same thing. So I consider these files to be duplicates. So the question now that becomes when we train machine learning models on code is that, let's say that you have this file in your training set and this file in your test set. Now, something bad will happen, and we'll get to that point soon. So now the question becomes, why are duplicates are a problem? And in this area of machine learning and source code, we have essentially the main premise in this case is that we want to train a model on a bunch of code. This could be the code that you have inside in your company. It could be open source code that you have in GitHub. But at the end of the day, we want to use the trained model to provide recommendations and insights on new and previously unseen code. So let's take some examples here. Let's take autocompletion. So when you invoke you have text dot, and you expect the machine learning model to give you a list of probable functions that you're going to use within this context. And most systems today, both Visual Studio Code, Eclipse, have systems that do that. Then you are interested in providing these suggestions to new, previously unseen code. If someone is copying and pasting code, is probably not needing autocomplete. The same thing, so essentially what this means is that, going back to this slide, is that we want to get these insights on new and unseen code. And we need to ask ourselves, for every time we use machine learning for some specific task, then the question becomes, is our tool going to operate on something that contains duplicates? And as we'll see later, there are a few of those cases that exist. So in code autocompletion, I hope I persuaded you that this is not the case. We also had this work that I briefly presented yesterday in a rebase talk, which is about finding variable misuses. So the high-level idea here is that our machine learning model looks at variables and says, well, look at this variable here. Well, do you see any other variable that is within scope, and there will be a type-correct replacement for this variable here that is more probable to be placed in this code? And in this case, this is a real bug that we've caught internally while we were dogfooding this in Microsoft. So now the thing is, again, this variable misuse task says we want to find misuses of variables on new, previously unseen code. We don't want to, if we found it once in some code that already exists, that's fine. We don't want to look at this code again and again. So this is, again, another case where our tool will be looking at new code, the new code that has not been previously seen. And the same thing happens, there are some work about predicting types. So there is JSNice from the ETH group, or the deep learning alternative that essentially looks at JavaScript and tries to migrate it to TypeScript and predicts types. Again, we're interested in the type code that is new, so a JavaScript file that we haven't typed already. If we have typed it, then that's probably fine. We shouldn't be looking at it. So again, this is an interesting example where duplicates would hurt us, because it's, if we've trained our system where somewhere in the training set we have duplicates, and then there are things that are duplicated in our test set, then what magically happens is we show, oh, we're really good at this task, but essentially what we are good at is just memorizing what we've trained on and predicting exactly the same thing on our test set. There are other cases where are a bit more contentious to some extent, whether we want to use duplicates or not. And I had a very lengthy discussion with both of the authors of these two papers. Again, I think this one has appeared in a software engineering conference, and this one has appeared in the programming languages conference, that in cases of deobfuscation, you might actually want to have duplicates. So what the authors of so Martin has been telling me is that what is happening is that we get in our system a lot of people inputting the same library, more or less, and trying to get a deobfuscated case. So maybe in that case, we actually need to encounter the fact that our tool, people will input here things that are duplicated. And in that case, maybe having those duplicates, it's perfectly fine. So I hope essentially to have persuaded you to some extent that in most cases we want to make suggestions for new, previously unseen code. And what this means is that when we have duplicates in our training and in our test set, things go a bit wrong. In the sense that we measure and we train the wrong thing compared to what our users are going to observe in real time when they actually use our tool. So where does this bias come? So just a slide of equations here, nothing terribly important. We have some quantity f that we want to estimate with our machine learning model. This could be the loss, it could be accuracy, it could be something like that. Now, if we computed this over our data set, we have essentially the average, the empirical average of this f invoked for each of our data points in our data set. But now let's assume that we have a duplication. So what this means, we can rewrite this data set D as a set of tuples, which is the example we have and a count, the number of times we see this example repeated again and again. So what this equation essentially says is that, well, if we didn't have duplicates, we would get this part here, and the duplicates contribute some extra bias. So if we are testing something and F is our accuracy, this means that this part here essentially kind of makes our accuracy, biases our accuracy to some extent in some form. So you can argue that this essentially, in the accuracy terms, what usually happens, and I'll show you concrete results about this later, is that this increases the accuracy that we measure in the end on our system. So we create a paper, we write a paper, we have duplicates, and magically we get a good number. But our users essentially are going to observe this, because the things they input in our system are not duplicates. They are new things. And this creates a question about how the evaluations of things that have happened so far, including some of my work, as I'll discuss, to which extent we can absolutely rely on those numbers, and in some cases we need to actually recompute things. So you can say, yes, but I've deduplicated the output and the corpus I have. And this is true. Most people have done this thing to some extent. Usually they filter out exact matches, so files that are exactly the same. And this is exactly what I did early in my PhD at some point. And I thought, yes, OK, I've now filtered out everything. Well, it turns out that 24% of those files are duplicates. So I think, I did this for a large set of corpora. Some of them have appeared in machine learning conferences, some in software engineering, some in programming languages. And then you can see that to a large extent, a lot of projects have good amounts of duplicates. So it means this is a problem that is quite wide and broad within this community of using machine learning for source code. So, OK, I've been discussing duplicates in a bit vague sense here, but let me go in some more detail. So we have, of course, our training set and our test sets. And in some cases, we have files that are duplicated. Now, we can have duplicates within our training set, within our test set. But most importantly, we can have duplicates that appear both in the training set and the test set. And these are of course, the worst ones. Because they kind of give hints to our model when we're testing it about things that it saw. So the model doesn't generalize well. So we've developed this terminology here, which we use this notation here. You can see there is a relationship between this notation here and here, where it kind of shades the part of its square based on where duplicates are. So we have essentially the following thing. We might be training on a biased data set, on a data set where we have duplicates in our training set, but our test set doesn't contain duplicates. So this is essentially the case of most existing models. We train them by mistake maybe on duplicates, and then what happened is that we deployed them, and the data that our tool observed as it was used, it didn't contain duplicates. So this is the unbiased test case. If we actually took the time to remove the duplicates from our training set, we have the fully unbiased case. However, what happens with the most existing papers is that we train on training sets and test sets that contain duplicates. So we get this fully biased, the fully biased case. So, OK, I've been talking a lot about duplication and effects. Now let me show you some numbers. We start with a simple language model. Language models are essentially machine learning models that can probabilistically predict the next token. These things are used usually in autocompletion, for example. And here, what you can see is a few measures that measure the performance of that model. What you can see, and this is the important number here, is that in most cases are the fact that when we trained and tested with duplicates, and when we tested without duplicates, it gives us a very different numbers. So you can see, for example, that accuracy, the accuracy of predicting the next token, drops by 10%. And, or numbers like perplexity or mean reciprocal rank that are important for those systems. So specifically also, these auto-completion systems can predict identifiers. Identifiers, things like variable names, string literals, numeric literals, and so on. And this because they are very rare, like there are many different variable names, too many different variable names, they're very sparse. You can see here that the accuracy on our ability to predict identifiers falls almost to half. And this is because we've trained on duplicates, we've seen the same variable names, the same string literals that may be rare, but they gave the perception that they were not rare because we had duplicates. So this is essentially a toy system where, a toy example, where I show you here that yes, duplication says that, well, if we evaluate on duplicates in our paper, we get a performance of 55%, let's say. But what happens is that our user will essentially observe this 49%, or worse, we get we think that our system performs 17% well, its accuracy in predicting identifiers, but it actually does 8.3%. Its accuracy is 8.3. So that's a problem, and this is, I think, one of the main reasons why duplicates are harmful. I'll show you in a moment how real systems, real papers that have been out there are affected. But this, using the simple language model, gives us one extra ability to play around with various parameters, and specifically with this notion of model capacity. So we have some parameters, some hyperparameters of our model that signify capacity, the amount of data, let's say, or information that our model can capture. There are many ways of doing this. We can do it by varying one specific parameter here that is well accepted within natural language processing. We do a lot of language modeling. So what you can see here now is two lines. The blue line is our performance of our system when we train on duplicates. And the black line is when we train without duplicates. And of course, this is the test performance on accuracy. What you can see is that as we increase the capacity of our model, yes, of course, our systems perform better and better. But now the systems that have duplicates seem to be performing much, much better. But this is just because they get more capacity, and within their capacity, they have the ability to memorize better those duplicates and perform better on those duplicates that appear on the test set. So in that sense, by increasing the capacity, we are cheating by memorizing the duplicates, but not learning much more about the actual problem that we're trying to learn. So you can see this for the accuracy over all tokens, and you can see this for the accuracy specifically of identifiers. That is essentially the worst, the hardest task that our model can implement. So this kind of essentially says that if we compare, on one hand it says that if we increase the capacity, yes, a large portion is used to memorize duplicates, but it also says that if we test different models under code duplication, it may not be indicative of the real performance. It may not be that one system overperforms the other. It may be that one system is just better at memorizing these duplicates and performing well on those duplicates. So essentially, the capacity thing is also something where we might get evaluations, either on papers or in practice. When we do an offline evaluation, we see that our system performs well, but this is not because of the model that we've just created, but because of the way it memorizes the duplicates it has. So we get this lesser performance. And you can imagine different models having slightly different curves like that here, which might affect them in how we actually compare them. So model capacity is an important thing. Okay, so this is a simple language model, really a very simple language model, but we can effectively run lots of experiments and get curves like that. Let's go on papers that have been published in many conferences. You might have heard of Code2Vec or JSNice or PHOG or other sequence-to-sequence models. So I think this has been published in an NLP conference. This has been published in a machine learning conference. This is in PLDI, and this is maybe last Uppsala or something like that. I don't remember exactly the thing, but a subsequent paper has been published elsewhere. What you're interested in looking is this red numbers. And you can see that the performance that it was reported, I mean, these numbers are not exact because I retrained them and I reshuffled the data set just to create an equal footing for all the data sets. You can see that the performance reduces substantially. So let's imagine that I was using this system here, which tries to predict the docstring given the implementation of a function. I measured performance of 13%, but what I get, a 13 blue score, that's a score to used in NLP's related tasks, but I actually have a score of 12 when I remove the duplicates. So this means my model has kind of memorized these duplicates. You can also see that different tasks and different metrics are affected differently, which was the same thing we saw before. So PHOG, this model from the ETH group in Zurich, you can see that when they're trying, it's an auto-completion model again. It's a slightly different one. It's not based on neural networks. These two are not based in neural networks. So I'm just trying to show that both neural network and non-neural network models are affected by this problem. And you can see that if we want to predict, when the model tries to predict the type, the type token, you see that the accuracy decreases only by 5%. But if we go for the most sparse things, the most rare things, which are usually string literals, like almost every program has many, many different string literals, then you see that the performance almost halves. I mean, it doesn't halve, it's less than 40%, but it's a huge difference. So it's not just my toy example that I've been showing you so far, it's also many real work, and this is just a small sample that I decided, let me take just some of the state-of-the-art work and see how is this affected. And it is. That's I think, the outcome. And again, the outcome is that sparser things like identifiers and string literals, seem to be affected the most. Okay, so with that, essentially, the question is, what I wanted to conclude with this paper is some best practice to avoid these issues with duplication, and essentially a recipe that people that are looking to use machine learning within programming languages and learning from big code, some principles to look at that I think should be the best practice that we should use from here on, and in research at least. So the first question is, when you are trying to tackle a specific application with machine learning for code, the question is, does my target application contain duplicates? When a user is using my tool, like type something and send something to my tool, will this inputs that my system will be accepting from the users contain duplicates? If so, then we don't need to do anything. But if the input from our users does not contain duplicates, we should remove our duplicates both for our training and our test set. So as a part of this paper, there is of course the wonderful implementation of Sorcerer CC, but I also have a very simple command line tool that essentially is exactly these three commands that you can throw it at your computer. Yes, it will take some computation time, but essentially it will give you for your corpus, for your data, what are the duplicates that you have at this point, and then you can use this list to remove them, for example. So essentially what I'm trying to do here is to lower the bar, and hopefully that helps with this problem. The other thing is model capacity, and I alluded to that earlier. We need to essentially tackle the problem of memorization when models with different capacities just tend to memorize duplicates. One thing is to start using stronger baselines that can also do the same kind of memorization. But also at the same time, use baselines that memorize well. So if you have heard of the k-nearest neighbors, which is essentially a method where you use all your points and you find the one that is closest to that, try that thing. It memorizes well. I mean, the model itself is just your training data. But then if your baseline, if a k-nearest neighbor's baseline does too well, then maybe you have a problem with duplicates. So I think with that, this is a kind of a list of these three main things that I would like to suggest to people to follow when they're looking at big code, at understanding, at using machine learning or something that learns from code and tries to extrapolate this to new artifacts. And I think that with that, we can get both better papers, better evaluations among different systems, but also it can really help us measure progress in such a way that we make systems that are really can be deployed and know how well they will perform when our users start using them. So thanks for your attention. Thanks for coming. I think we have 4 minutes for some questions. Yeah, of course. So in everything I presented is file level duplication. So the files that are very similar, the whole file. Yes. So I think at this point, the main thing is removing the absolutely duplicate thing. So currently, I'm using something that Sorcerer's VC has in its implementation. So it creates a vector for all the tokens that it contains, and then you compute the Jacquard similarity between two files. And I'm using a Jacquard similarity, I think, of 70 or 80%. It's in the paper, exactly these numbers. I did a manual, meaning myself. I looked at 100 pairs at random. I was fully satisfied with all 100 of them. They all seem to be actually things that I would call duplicates. So we can start lowering this down. I haven't had time to do that. The one thing that I mentioned in the paper that I haven't discussed here is that you don't have to remove the duplicates per se. You need to downweight them. So if you have two files that are duplicated or that maybe have some differences, you can argue that in my accuracy, in my loss function, in my objective that I'm trying to optimize, let them count for 50%, like for 0.5 of a real document. So together, when summed together, they count as one document. Overall, I don't think there is, a unique threshold that I can tell you this is the magic number. Everything beyond or above that is the good or bad way of doing this. So, yeah.
I have heard that in some cases people duplicate the training examples on purpose so that they have balanced labels.
Mm-hmm.
So is this now unprofessional?
So in training, you're allowed to do anything you want in general, right? As long as your tests, you have examples in your test set that are new and previously unseen. That's my high-level recommendation. Like, as long as you're tested, it's something that is new, that's fine. If your training procedure, which is true, like the class imbalance problem, is present in many cases, if you need somehow to tackle this problem for your model to train, then by all means do that. That's fine. As long as there are no copies from the training set to the test set. And also copying the full data set twice is better than, let's say, copying 5 files from the data set 10 times and leaving the rest of the data set, the training set, as is. Yeah. Sorry.
operators or unrolling loops, all that kind of stuff. If you're training on code, would be available to you to kind of
Yeah.
expand that set and say, okay, now if I do all this analysis on the abstract syntax tree, I can find duplication. Would that be worth doing or not worth doing?
So I think this is application dependent. If you, for your application, you want essentially to say that two sorting functions, bubble sort and quick sort, are duplicates for some reason, I'm not sure, I mean, maybe eventually we'll have such applications, then maybe it's worth doing this, this kind of duplication. If you're interested in auto-completion, where one implementation of bubble sort and one of quick sort is probably fine to have, then no need to change it. So I think it's based on the application, based on how you expect your users to actually use a deployed model and what it would constitute to them like a duplicate. Like, will they be, I mean, will they create a sorting method twice or 10 times? Or this happened once and no one will ever create a sorting method again? I mean, that's an extreme example. But I think this is a question that we need to ask ourselves for every application and answer it individually for every application and the setting that we're looking at. Yeah.
The way you describe it, I want to think about how the way you care about how the file was actually created. So like for autocomplete, you care about who the programmer actually trying to source them. If they copy and paste the file out of the repository, you didn't care about that. They didn't check for them.
Yeah, I totally agree.
So I personally tested some kind of machine learning with code examples, and when I tested, I found that when I predict from the beginning of the program, then it generates the license agreement because the programs have exactly same the license agreement. So I guess this is not duplicate in your sense.
We ignore comments, at least in when I've done here. Like, I remove comments when I compute the duplication, how similar two files are. You can argue that you can add those things in, and it might make sense if you want to. There is an auto-completion tool out there that does everything from comments to everything, and at least it tries to. And yes, you can argue that this is something that you should remove that. And I mean, maybe since it's also a PL conference here, it's a good question. Why do people feel the need to copy-paste code, to duplicate code? In some cases, I think that's a reasonable thing to do, like I did for myself. But maybe there is some interesting programming language question here. Can we help developers not do that, maybe? Or help them solve the problem they're trying to solve, which I don't really know what is it. Like, I cannot give you a categorization. I think there are some empirical works about that, but yeah.
Anything else?
Yeah.
So I think that's one of the reasons of why we might have duplicated codes, and maybe I'm wrong, but if you have some insights on this. So you can imagine that you are working, let's say, on a TypeScript project or JavaScript project, and you install some dependencies, and then JavaScript will bring a bunch of code. But then I'm a bit sloppy and I did not add those files to my git ignore. So I will commit to JavaScript itself. Are you doing anything to exclude that?
These are found automatically by this method, and yes, people have done that. I think the best paper is this deja vu paper that was originally mentioned, that I think they have explored a lot of those causes, and this is a beginner. You have some. Yeah.
Yeah, I see your point. Yeah. It's like if Google explicitly does that, where we all use the same version of the dependency. And there's probably people who are doing that as well. Yeah, yeah.
And I've seen, like in C# people taking a library, taking copy-pasting it, changing the namespace, and then adapting it to their project. Yeah. Sometimes it's easier. Yes, you may have debt that you need to pay in the future. But sometimes the reality of the software development is you need to get something done fast.
One more question.
Of course.
Identifiers unique to particular project. So if there's one project which uses a very unique identifier throughout in this case, but if you use for machine learning and split the sum of the files in this project to the testing case and the evaluation case, then it is also kind of a duplication at the identifier level.
Yes, again, I think it depends on the application. If your application ignores all identifiers, then you're probably fine. But if you, like, some identifier, something about identifiers is duplicated, then you should try to remove it. And yes, I guess identifiers are, like, from a data science style perspective, looking at the code, are the thing that are the sparser, the most rare thing in the code. And a lot of effort has been spent on how do we actually model them in a good way. And you'll see in most of those cases, you can see whether two files are duplicated by just looking at their most rare kind of identifier. If they have something that is, you see it feels very unique. And you kind of know that this is duplicated. I sometimes did that, like I had a big code base and I wanted to find a file. I didn't know exactly what, but I knew that this identifier seems to be both unique and relevant to that. Let me grep through the whole code base. And yes, this file, for example, seemed to have it because it's so rare, because we get natural language word, we concatenate them together in camel case or in underscores, and then we create something relatively unique.